Good morning. Thank you very much for attending. My name is Uriel Radois. I'm a mechanical engineer specialized in smoke control. I'm a member of the Smoke Control Project Department at SODECA. Today, we are start a series of 4 webinars focused on pressurization systems for evacuation routes. This first webinar is about the objective of a pressurization system and the system classification according to the European standard EN 12101/6. The second webinar will be about airflow calculation for fan selection. The third webinar will be about the components of the pressurization system. And the fourth webinar about the new European standard for design, installation, and maintenance of pressurization systems, the EN 12101/13. Your microphones are on silence mode in order not to disturb the listening of other attendees. If you would like to ask me a question, please write it in the question box of your panel, and I'd be glad to take all your questions at the end. Okay, let's start with this first webinar. Pressurization of escape routes, objective of the system, and system classes according to the EN 12101/6. We will see 3 different parts. First of all, the objective of the system and functioning principle. The second one, the 6 different classes according to this standard, the 12101/6. And finally, the different spaces to be pressurized. Well, the objective of a pressurization system is to create a smoke-free protected space, either for the safe evacuation of people, for firefighting, or for property protection. To achieve this objective, the pressurization system must create a positive pressure between the safe area, the escape route, typically the stairwell, and the adjacent accommodation area, so that smoke from fire does not spread through doors gaps into the protected area. The aim is to establish a pressure gradient and thus an airflow pattern with the protected escape space at the highest pressure and the pressure progressively decreasing in areas away from the escape routes. This is achieved by pressurizing the staircase and optionally the lobby, so that the pressure in Zone A, the stairwell, is higher than the pressure in Zone B, which is at the same time remains higher than in Zone C, the accommodation area, let's say the office, the hotel rooms, the apartment. Thus, the airflow will flow from areas with higher pressure to areas with lower pressure, preventing the smoke from spreading from Z, the accommodation area, to B, to the lobby, and from the B, the lobby, to Zone A, the stairwell. Okay, now you know the objective of the system. The following step is to think about what happens with the doors when people are evacuating the building through the evacuation route, let's say the stairwell. There will be doors opening and closing, so 2 scenarios will coexist. First one is the closed door scenario, when all the doors are closed. In this case, a high enough overpressure level in the staircase with respect to the unprotected area, the accommodation area, will prevent the smoke of spreading into the staircase. This overpressure must be maintained in zones A and B, stairwell and lobby, so that the airflow always goes from the protected zone to the unprotected zone. But we have to bear in mind that if this level of overpressure is too high, it could impede the opening of doors connecting the stairwell and the accommodation area. So it's necessary to maintain an appropriate balance between the minimum pressure to prevent the spread of smoke into the stairwell and the maximum pressure to allow the opening of doors. Bear in mind that doors, exit doors at every level, open from the protected area to the unprotected area, from the accommodation area, from the office, for instance, to the stairwell. The second scenario is the open door scenario. In this case, the area between the protected area, the stairwell, and the accommodation area will be much larger, so the pressure tends to equalize between both zones, the stairwell and the accommodation area. So the pressurization system must quickly increase the airflow supply into the protected zone to provide a minimum air velocity through the open door. In this video, you can see an office building with a stairwell, lobbies, connecting the office area and the stairwell. You can also see two pressurization pieces of equipment, one for the stairwell and the other one for the lobbies. In the event of a fire, the smoke detection system will give a signal to the pressurization equipment in order to activate it. And will start supplying air into the stairwell and into the lobbies, and the system will control the level of overpressure not to exceed 50 pascals in order not to avoid the opening of doors. When any door is opened, the pressure in the stairwell will drop and the system will increase the amount of air supplied into the stairwell in order to create a minimum airspeed through the door. When doors close, the system will reduce the amount of air supplied into the stairwell in order not to exceed the 50 pascal. In this other video, you can see this mock-up with a pressurization system installed. In this first scenario, the pressurization system is not working. We have a natural ventilated stairwell with some openings at every level. We have filled the accommodation area with the smoke, and you can see that this smoke spreads into the stairwell. In this other scenario, we have activated the pressurization system and we are trying to apply the conditions for a system class A. We will see the classes of systems later on. In this case, you can see that the smoke does not spread into the staircase. For a class B system, the airflow criterion is to have minimum 2 meters per second through the door between the stairwell and the accommodation area. And finally, for a class C system, apart from two other criteria that we will see, there's a third one requiring a minimum of 10 pascal pressure difference between the stairwell and the accommodation area with the exit door open. In In this other video, you can see a smoke test we carried out in a car park. We had this stairwell with a pressurization system installed. So even with the car park filled with smoke, the smoke did not spread into the staircase. Well, now it's time for the 6 different classes of systems you can find in the European standard, the EN 12101 Part 6, specification for pressure differential systems. These 6 different classes are meant to be applied in buildings depending on the building use and the associated risk level. Before starting with Class A system, that is the first of the classes, I would like to say that there are 4 of the 6 classes that are meant only for means of escape. It means that they are only meant to protect the stairwell from smoke spreading during the evacuation time, and there are 2 other classes that are meant for means of escape, but also for firefighting. It means that they have to protect the stairwell during the fire fighting period. Bear in mind that the more time passes, the more ferocious the fire becomes. So with these 2 systems that are Class B system and Class F system, we will need more stringent criteria. So let's start with Class A system. This is for means of escape, and in the standard you will see that it is called defend in place. What does it mean? It means that we can apply this system in buildings that will not be evacuated unless are directly threatened by the fire. The level of compartmentalization is normally safe for the occupants to remain inside the building. Therefore, it's not very likely that more than one door will be open at the same time in the protected space. So the criteria that we have to apply for the system is the pressure difference criterion with all the doors closed, that it has to be a minimum of 50 pascals, and the other criterion is the airflow criterion, and it says that the air velocity through the door between the protected area and the accommodation area has to be at least 0.75 meters per second. The number of doors considered open in this case is only 1, the door at the fire level. Okay, so we have these 2 criteria where we will see calculations on the following webinar, and we have to carry out the calculations for both criteria, and when we are selecting the fan, we will choose the greater value. The Class B system is one of the 2 meant for means of escape, but also for firefighting. And this kind of system may be used to minimize the possibility of serious smoke contamination of the fire control stations during the evacuation of persons and while the firefighters are extinguishing the fire. Actually, when for firefighting, this system is thought for firefighters to take the fire fighting lift till the level just under the fire level. They can go to this lobby, connect the hoses here, and just go to the fire level and tackle the fire. So in this case, we have to pressurize 3 different rooms: the stairwell, the lobby at the fire level, and the firefighting lift. And we have 2 different criteria: the pressure difference criterion with all the doors closed, that is 50 pascals for the stairwell, 50 pascals for the firefighting lift, and 45 pascals for the lobby. And then there's the airflow criterion that it says that the system has to achieve this 2 meters per second through the door between the lobby and the accommodation area at the fire level, but with a number of doors open that are the door between the stairwell and the lobby at the fire level, between the stairwell and the lobby at a level just under the fire level, with the door of the firefighting lift open, and also with the exit door open. We have to achieve this 2 meters per second with all these doors open. A Class C system is also one of the 4 that are meant only for means of escape, but in this case is different from Class A. In this case is for buildings that will have a simultaneous evacuation. So all the occupants of the building will be evacuated at once, and the occupants will remain alert and ready and be familiar with the area in which they are moving, typically an office building, for instance. And it will be that the evacuation time will be not so long in this case. So in this case, we have to consider 3 different criteria. The pressure difference with all the doors closed, that is minimum 50 pascal, the same as we have seen in Class A. The airflow criterion of 0.75 meters per second, the same as in Class A, but we have a third criterion, that is the pressure difference with all the doors closed, but with the final exit door open. And this criterion is of 10 pascals. So is this one, okay? All the doors closed, the exit door open, and we have to achieve these 10 pascals. When we carry out calculations, this criterion is typically the most demanding criteria of airflow to be supplied into the staircase. The Class D system is again for means of escape, but with a slipping risk. It's typically used in hotels, shelters, and boarding establishments. And the time necessary for the occupants to move to a protected space, let's say the stairwell, before reaching the final exit may be longer, because in this case, they can be sleeping, so this time will be longer. And this is why, instead of considering only 1 door open, we have to consider 2 doors open for this criterion of 10 pascals, apart from the exit door, another door. And for the airflow criterion, also 2 doors, the one at the fire level and the exit door. When we have more doors open, the requirements of air to be supplied into the staircase will be much larger. And the last class meant only for means of escape is the Class E system. And in this case, is meant for phased evacuation. This is for just big buildings that it's not possible to carry out simultaneous evacuation, and the evacuation of people has to be phased. So the evacuation time will be much longer, sorry. So in this case, the standard says that instead of 2 doors open that we had in the Class D system, we have to consider 3 doors open. So now you can see that we will have, if we carry out calculations for a Class A system, we will have an airflow to be supplied into the staircase. More airflow if we consider a Class C system, sorry, even more for a Class D system, and even more for a Class E system. These four, A, C, D, and E, only for means of escape. And Class B and Class F, this final one, are meant also for firefighting. In this case, it's more or less the same as we had in Class B, but it's typically used when we have two different accommodation area. And in this case, the requirement is to have 2 meters per second in the door between the stairwell and the lobby, and 1 meter per second in through the door between the lobby and the accommodation areas, with the door between the stairwell and the lobby closed. In this table, we have a comparison of the airflow that we have to supply to the stairwell to achieve the different criteria that we have seen before. Only just for this comparison, 3 classes, all of them meant for means of escape: Class A, Class C, and Class D. For the closed door criterion, 50 pascals, all of them are the same value because the criterion is the same for these 3 classes. For the 10 pascals criterion, with a number of doors open, with Class A, we don't have this criterion, Class C, only with the exit door open, and Class D, the exit door and another one. So we have these different values, okay? And finally, for the airflow criterion, it's the same for Class A and C because we only had to consider one door open, the one at the fire level. But for Class D, we have to consider the door at the fire level and also the exit door. That's why we have such a difference in these 2 numbers. Finally, today I'm going to talk about the different spaces to be pressurized. If we have the stairwell just connected to the accommodation area, we have only to pressurize the stairwell. If we have a lobby between the stairwell and the accommodation area, it depends. If this is what the standard says is a simple lobby, we don't have to pressurize the lobby. What is a simple lobby? A simple lobby is a lobby that only has 2 doors. The one that connects the lobby with the stairwell and the other one that connects the lobby with the accommodation. In this case, it is not necessary to pressurize the lobby. But if the lobby is not a simple lobby, for instance, if it has a door connecting the lobby with the lift shaft, then the lobby has to be pressurized. But instead of different pressure between of 50 pascal, that is the required between the stairwell and the accommodation area, the requirement here is of 45 pascal. Alternatively, if we have a lobby that only connects the stairwell, the accommodation, and the lift shaft, we can pressurize the lift shaft, and then and in that case, it's not necessary then to pressurize the lobby. If we have to pressurize the lobbies, we have 2 options: pressurizing the stairwell and the lobbies of all the levels at the same time, or pressurizing the stairwell and only the lobby at the fire level. If we choose the second option, typically for high buildings, because bear in mind, if you have a requirement of, let's say, 3,000 cubic meters per hour for each lobby, if we have only 2 lobbies, okay, it's 3,000 multiplied by 2 is only 6,000 cubic meters per hour. But if we have, let's say, 10 stories, then 3,000 multiplied by 10 is 30,000. And it will require big ducts. So we will need a lot of room. So in this case, it's typically use the pressurization of only the lobby at the fire level. In this case, we need motorized dampers at every level in the lobby. So in the event of a fire, only the motorized damper at the fire level will open and all the other motorized dampers will remain closed. We have these two pieces of equipment, this pressure differential sensor Modbus and this PDS lobby control that are useful for pressurization of lobbies in order to control the level of overpressure between the lobby and the accommodation. And that's all for today. Thank you very much for your attention. I am going to try to answer questions if I see questions in the control panel. Just 1 second. Here, questions. Oh, yes. The first question is, hello, the classes are changed according to the 12.101 part 13. Yes, the classes are changed. We will see it in the fourth webinar. I will talk about the new 12.101 part 13 standard. But bear in mind that this standard is not required in all the countries at the moment. There are some countries that they are requiring the new standard, but not all of them. So for us, important to share this information about both standards, 12.101 part 6 of 2005, and in the fourth webinar we will see the differences between this 12.101 part 6 of 2005 and the new 12.101 part 13 of 2022. Okay. If there's any other question, I will be glad to answer, but at the moment I only see this question. I will just wait a couple of minutes if there's anyone who wants to ask anything else. Sorry. Okay, if there are not other questions, yes. For a hospital, which class is the best suited? I would say class D, the one for sleeping risk. Okay, show you your class D system. Okay, at least this one. In some countries, I have seen the requirement of a class B system. It will depend on the fire consultant or the authority having jurisdiction. In some countries, class D is enough because they say that the stairwell is only meant for means of escape. So if the system is only meant for means of escape, the class D system would treat very perfectly well. But in other countries, there is the requirement that the system also has to be for firefighting. So then a class B system would suit better. Now I see other questions, just 1 second. Can we have a detailed schematic regarding automation of lobby pressurization with SODECA equipment? Yes, we have some schematic drawings for this, but I would suggest regarding it to your distributor or the contact you have in your country, and then they will email us, and we can give you this schematic drawing for sure. Before I forget it, let me show this presentation in PDF format. I will just 1 second post it in the documents area. Just 1 second. Yes, here. I'm going to post it here. It's charging. Okay. I have just shared this presentation in PDF format. Okay. Someone is asking for a video for this webinar. Yes, I'm not in charge of this kind of videos, but we have a communication department that I think that maybe they will post it on our YouTube channel. But if not, you can ask for it to your contact, please, in your country. All those directives, EN Part 6, are available for public online. No, they are, you have to pay for them. You have to pay. All these EN standards, yes, they are not for free. They are public, yes, but not for free. You have to pay for them. Is the rest home for elder people simulated for a hotel or hospital? Yes. All these buildings where you can find people sleeping, Class D system is the best option, unless the authorities having jurisdiction or the fire consultant requires that the system is meant also for firefighting. This is the difference. When the system is only meant for means of escape, okay, to protect the stairwell during only the evacuation time, and you have people sleeping in there, Class D, Denmark system is the correct choice. But if the system has to be also for firefighting, then it's better the Class B system, or Class B system would be the best choice. Okay, so I cannot see more questions. Just invite you to the second webinar that will be next Tuesday at the same time. So thank you very much for attending, and see you soon.